Today we're going to be discussing even and odd functions. So the question that you want to answer is, what are even and odd functions? We're going to describe even and odd functions in two ways: graphically and algebraically. Okay, so let's first describe even functions graphically. An even function described graphically by using a graph. It's a function or graph that has line symmetry. Okay, so graphically speaking, we're talking about being able to look at a graph to determine if it has line symmetry. When I say line symmetry, I'm talking about a vertical line that will cut that graph in half. The only vertical line that we can use that gives us the line symmetry is the y-axis. Any other vertical line doesn't work. Only the y-axis. So I wrote y-axis right there underneath. Now, these are two examples of graphs that have line symmetry. As long as this is the y-axis, as long as the y-axis is the line of symmetry. Notice that you can cut these two graphs in half and then fold them onto each other like they're mirror images. You can look over here on our wall of functions and see that a quadratic function is an even function. Are there any other even functions up here on this wall of functions?
The absolute value.
Absolutely. Absolutely. All right. But none of the others are even functions because none of the others can be cut in half with the y-axis. Okay? Now, having seen what it means graphically speaking to be an even function, I also want you to notice that both sides of this function face up. Of these functions face up. They could also both face down, but if it's going to be an even function, both sides have to face in the same direction. Both ends. Now, does that mean for a fact that it's an even function? No. Because you could have a function that looks like this. Okay? Do both of those ends face up?
Yes.
Yes.
Yes, but it's not an even function because you can't cut that thing in half to make mirror images. So this is not an even function, even though both sides do face up. But it's a good clue to look for because every even function will have both sides that face in the same direction, whether it's facing down or facing up. So it's a good thing to look for. All right, let's talk about the algebraic definition of even functions. Now, you're not going to know what this means right now, and that's fine. I'm going to explain it later in more detail. Algebraically speaking, f of negative x equals f of x. I'll try to give you just a very basic understanding of that in just a minute. Let's give just a basic representation of what this means. If I'm given a function, let's say it's the quadratic function. I know that it's even. If I plug in a negative 2 for x, what's negative 2 squared?
Negative 2 squared is...
Who said it? Somebody said it. 4. It's positive 4. Negative 2 times negative 2 is 4. If I plug in a positive 2, what do I get? 4. So it doesn't matter if I plug in a negative or a positive version of the number, I get the same result. That's what it means to be even. It doesn't matter if you plug in the x or the negative x, you're going to end up the same. Okay, that's how we think of it algebraically. All right, the next thing that we're going to look at is an odd function. Now, an odd function, graphically speaking, it's a graph that has rotational or 180-degree symmetry. saw the quadratic and absolute value functions were even. That means of our wall of functions, some of these are probably odd. Some of them may be neither. One example of an odd function is the cubic function. Now I want you to visualize this function. If I were to take this function, and it looks like a propeller, doesn't it, for an airplane. If I were to flip it upside down, it would look exactly the way it does right side up. Anytime, and that would be a rotation of 180 degrees. Anytime you can rotate an object about some point, the point of rotation, 180 degrees, and it lands back on itself, that's an odd function. So our examples of odd functions are the cubic function here that's first. Here we have a linear function. A linear function is an odd function as well. And here's another function. This is actually what we call a sine wave, or the sine function. All right, a sine function. You'll learn about sine, cosine, and trig functions a little bit in geometry, and then more in pre-calculus. If you choose to take that. So all of these functions here can be rotated 180 degrees, and they'll land back on themselves. Now, what's also interesting about odd functions is that their ends always face away. They always go in opposite directions. But does that mean that it's an odd function? Not necessarily. Every odd function will have ends that go away from one another. But just because the ends go away from one another doesn't mean it's an odd function. But it is a good clue to look for. All right, the next thing is the algebraic definition of an odd function. Algebraically speaking, f of negative x equals negative f of x. F of negative x equals negative f of x.
Are we going to be taking a test on this?
What you think?
Yes, sir.
So this Friday, like you said.
Yes, sir.
This looks easy.
Okay. Now, algebraically speaking, if I plug in a negative value, I'm going to end up, or let's just say negative x instead of x. If I plug in negative x, I'm going to get the opposite of what I would have plugged in if I just plugged in x. So in other words, if I plug in a negative 2, I'm going to get the negative version of what I would have gotten if I plugged in a positive 2. So I'm going to get the opposite of the original if I plug in the negative x. Now again, we're going to talk more about this in just a minute. Okay, so everybody should have this little handout in front of you. This handout deals with even and odd functions. So let me just read through what this says, and when you watch this on the video, you can follow along again. It says, you learned about line and rotational symmetry in previous math classes. Remember that a figure has line symmetry if there is a line that divides a figure into two parts that are mirror images of each other. A figure has rotational symmetry if the figure aligns with itself when rotated about its center by an angle of 180 degrees or less. A figure can also have point symmetry. A figure is symmetric about a single point if, when rotated about that point 180 degrees, it aligns with itself. This is the kind of rotational symmetry that we are dealing with for odd functions. Rotational symmetry of 180 degrees is point symmetry about the center. So what you're going to do is you're going to look at these logos that you see here. All right? And on those logos, you're going to go through and... All right, so we're looking at the first 10 of these problems. Now this first one is kind of hard to see on the video, but that's a McDonald's symbol. And so what type of symmetry does it have?
L.
L for line. Okay, number 2?
B.
B for both, because it has both line and, if you cut it like this, you can cut it in half. If you rotate it, it rotates back onto itself. All right, what about 3? L for line. Good. What about number 4?
B.
Nope.
R.
Just R for rotational. It's only R because these are slanted. If you cut that in half and flip it onto itself, it's not going to match up perfectly. All right, what about number 5?
L.
L for line. What about 6?
B.
Nope. 6 is also line symmetry. You can only cut it this way. All right, you can't rotate it onto itself. All right, what about 7?
L.
L for line. What about 8?
L. No.
Yep. What about number 9?
L.
It's both. It has line symmetry because you can cut it in half this way. It also has rotational symmetry of 120 degrees. There are 3 points to this. 360 divided by 3 is 120, so you can rotate it 120 degrees and it will land on itself. All right, number 10.
L.
Actually,
B.
No, it's
B for both. It has line symmetry. It also has rotational symmetry of also 120 degrees because 360 divided by 3 is 120. There are 3 segments here. All right, so we can go. You can go over the rest of those on your own. Now, let me talk about this next part over here. It says, now let's look at the graphs of the parent functions or for symmetry. Starting with an even function. We're just restating what we've already said. A function is an even function when f of negative x equals f of x. The graph is symmetric about the y-axis. For example, y equals absolute value of x. You can take that line, the y-axis, cut it in half, and fold it onto itself. So the trick is, can you fold the graph in half along the y-axis and it aligns perfectly? Well, if it does, then it's even. All right, an odd function is a function where f of negative x equals negative f of x. That means we're getting the opposite of what we had for the original after I plug in negative x. So the graph is symmetric about the origin or rotated 180 degrees about the origin. For example, y equals x cubed, which is our cubic function. Can you rotate the graph upside down or flip the graph over the y-axis and then the x-axis and it still looks the same? Then it is odd. But if it's neither even nor odd, then it is neither. A function is neither even nor odd if it does not meet the requirements to be an even function or an odd function. So look at example 2. Decide if the following graphs are even, odd, or neither and explain. All right, so what do you think about A?
Even.
It is definitely even because the y-axis is the line of symmetry, so you write even. What about B? Odd. I know it's odd because if I rotate it 180 degrees, it's going to land on itself. All right, what about C? Neither. Can you cut it in half?
No.
No. Can you rotate it 180 degrees and it lands on itself? No. All right, what about D? This is the rational function.
That's not.
Neither.
Yeah, neither.
Odd.
Can you rotate it 180 degrees and it land on itself?
It's both.
Yes. Nope, it's just rotational, which means it is odd. Okay? All right, we're going to skip example 3 because I want us to talk about the problems on the back. So let's go to the back now. Okay, the top of this worksheet is more of the same. You can actually go to your notes and you can fill in these blanks with what needs to be there. So I'm not going to do those right now. But I am going to talk about how we're going to do these problems. Now, they give us a function. Notice the function is f of x equals x squared minus x. Let me zoom in a little bit more. All right, and then they show the function in the form of a graph. Now tell me, from that graph, is this even, odd, or neither?
Even.
It is neither. The reason that it is neither is because the y-axis does not cut it in half, because it's shifted over a little bit. So it is definitely going to be neither, but we have to prove that. Here's how we're going to prove it over here where it says algebraic proof. We are going to, instead of plugging in x like the original function had, we're going to plug in f of negative x. So everywhere there's an x, you're going to plug in a negative x. So what we're going to have is parentheses negative x squared minus parentheses negative x. Look what I did. Ethan, look what I did. I plugged in a negative x everywhere there was an x. I had an x squared minus x to start with. So I plugged, hold on just a second. So I plugged in negative x everywhere there was an x. I'm going to rewrite the original function right here. Alright, so what do we get when I square a negative? Positive. So this becomes positive x squared. And what happens when I take a negative and a negative? I get positive. Now let's compare this to the original. In the original, I had an x squared. Do I also have an x squared in this one? Yes. In the original, I had a negative x. But in this one, I have a positive. So are those the same? No. So part of it is the same and part of it is opposite. So the result would be neither. If it's even, you're going to get exactly the same function that you started with. If it's odd, you're going to get exactly the opposite of the function you started with. If it's a little bit of both, it's neither. Okay, let's take a look at the next function. Alright, in this next function, we have parentheses x plus x cubed raised to the fifth. I know it's hard to see on the screen, but you can see it on your paper. Now, look at the function. This is clearly a what type of function? Look at the graph. It's odd. Why? Because you can rotate this thing 180 degrees, and it looks exactly the way it did when I started. Okay, after I flipped it over, it looks exactly the same. All right, now, let's prove it algebraically. So I'm going to rewrite my function. F of x equals parentheses x plus x cubed raised to the fifth. Now, everywhere there's an x, I'm going to plug in negative x because that's how I test it. I test it by plugging in negative x. So what I'll have is parentheses again, negative x plus parentheses negative x cubed and then raised to the fifth. So let's simplify. So negative x is just negative x, right? So let's write that. Negative x cubed would come out to be what? Positive or negative? Negative. So negative x cubed raised to the fifth. So tell me, is this thing exactly the same as the original or is it exactly the opposite?
Exactly right.
It's exactly the opposite. So that confirms that it is odd. So these are the way, this is the way you're going to do the rest of these problems. You're going to do the rest of the worksheet, 4 problems. You have to give me your prediction as to whether it's odd, even, or neither, and then show the proof to the right. All right, do this for homework.